Good evening, everyone. This is Faaiz from AIIMS Nagpur. Yeah, I'm doing final year MBBS, and I have cleared NEET exam on 2020. So I have secured All India rank 3056. So today, our session will be, see, you have been sent almost 13 questions. So I will be discussing each questions in detail. Okay. So बीच में कोई doubt आएगा तो you can ask. Okay, so without wasting any time, okay, so I'm starting the session. Okay, so this is the first question. The question is how to convert Kelvin into degree Celsius. Okay, this is a common problem from thermal properties of matter, like converting Kelvin to Celsius, Celsius to Fahrenheit, like vice versa, Kelvin to Fahrenheit and all. So we have a general equation for that. Correct? What is the equation? How did see? We got the equation from these scales only. Kelvin scale. See, we have three scales: Kelvin scale, Celsius scale, and Fahrenheit scale. Clear? Okay. So see the Celsius scale. Okay. See the Celsius scale. See the upper point in Celsius scale is 100 degrees Celsius. Correct? And lower point in Celsius scale is 0 degrees Celsius. Okay. So so we have to do is like degree Celsius by upper limiting point minus lower limiting point. So here it will be upper limiting point is 100 and lower limiting point is 0. Okay. Then we can equate these to Kelvin scale. How? Like Kelvin divided by, see, here actually 0 degrees Celsius minus lower limiting point. Lower limiting point is 0. So here in Kelvin scale, see the generally we can say what? So suppose the scale is x minus lower limiting point, x minus lower limiting point divided by upper limiting point minus, I'm taking lower limiting point as LLP. Okay, so like LLP. Correct. So here see, for degree Celsius, it is degree Celsius minus 0. It is degree Celsius minus 0 divided by 100 minus 0. Like similarly, we can equate with the Kelvin scale. Kelvin scale, see the Kelvin scale. In Kelvin scale, lower limiting point is 273 degrees Celsius. Correct? In Kelvin scale, LMP is 273. In Kelvin scale, upper limiting point, that is 373. Upper limiting point means ULP. Correct? Okay, I can give an abbreviation of ULP for here. Easy. Okay, so upper limiting point is 373 Kelvin and lower limiting point is 273 Kelvin. Okay, so in Kelvin scale, we have to take Kelvin minus lower limiting point is how much? Lower limiting point is 273. So 273 divided by upper limiting point minus lower limiting point. Upper limiting point is 373. Correct. Lower limiting point is 273. Okay. And similarly, we can equate this with the Fahrenheit. Same approach. See, approach is same. Okay. Approach should be same. Like so the scale minus lower limiting point divided by upper limiting point minus lower limiting point. This is the basic funda. Okay. Okay, this is the basic funda. X minus lower limiting point divided by upper limiting point minus lower limiting point. So similarly for Fahrenheit scale, see the Fahrenheit scale here. See the Fahrenheit scale. For Fahrenheit scale, lower limiting point is actually lower limiting point is what? Yeah, melting point of water, and upper limiting point is boiling point of water. Okay. And here for Fahrenheit scale, lower limiting point is 32 degree Fahrenheit. Lower limiting point is 32 degree Fahrenheit. And upper limiting point in Fahrenheit scale is 212 degree Fahrenheit. Okay, it's clear enough? Okay, I hope it's clear. So for Fahrenheit scale, we can write, degree Fahrenheit minus yeah, the lower limiting point. See, the lower limiting point is 32. 32 divided by upper limiting point. See, the upper limiting point is 212. So 212 minus 32. So, see here, see. So we can write degree Celsius divided by 100 minus 0 is 100. 100 minus 0 is 100 is equal to K minus 273 divided by 100. 373 minus 273 is 100. Barabar, which is equal to degree Fahrenheit minus 32 divided by 212 minus 32 will be 180. It's clear? Okay. So this is the equation. Using this equation, we can solve any converting question. Converting question in the sense converting Kelvin to Celsius, converting Kelvin to Fahrenheit, anything we can solve using this equation. So the basic concept is I have explained now, and the equation we have to remember is degree Celsius. See, degree Celsius divided by 100, which is equal to Fahrenheit minus 32 divided by 180, which is equal to Kelvin minus 273 divided by 100. Okay. Yes. So suppose, for example, I want to convert anything. See, if I want to convert 37 degrees Celsius, to Kelvin. Okay. So I can do like using this equation. Okay. So I can separately take degree Celsius here, 100 by 100, which is equal to K minus 273 divided by 100. So 100 I can cut, correct? So I will get like Kelvin minus 273, which is equal to degree Celsius, and Kelvin is equal to degree Celsius plus 273. Clear? Okay. So I want to convert 37 degrees Celsius to Kelvin. So 37 degrees Celsius plus 273 will be how much? 273 plus 37, 280. So 3110 Kelvin. Okay. Yes. So we can convert anything. So the question was how to convert Kelvin into degree Celsius. I have been explained very beautifully. This is the basic funda: x minus lower limiting point divided by upper limiting point minus lower limiting point. And see, the equation is degree Celsius by 100, which is equal to degree Fahrenheit minus 32 divided by 180, which is equal to K minus 273 divided by 100. Okay, using this equation, you can convert anything. Okay. So I hope you got this. Okay, so let's move to question number 2. Okay, let's move to question number 2. Question number 2 is from current electricity. Okay, so let me read the question first. We have 12 resistors of resistance R. Okay, we have 12 resistors of resistance R. We have 12 resistors, and each resistor have the resistance of R. Okay, it is connected to each other is the form of a cube, and the bottom face is connected to a battery V through opposite corners of bottom face. Opposite corners of bottom face. We have to find current in each branch. Okay, we have to find current in each branch. So see, this is the diagram. Okay, this is the diagram. So we have to find current in each branch. Okay. So let's solve this. So battery is been connected here. Okay, here it is. We have a battery here. Okay. Suppose the voltage is V. Okay. So the approach is we can solve like this. Suppose current I is coming through this branch. Okay. Current I is coming through this branch. Okay. Current I. So current I is entering this junction. Okay, so this current has to divide, correct? This current has to divide. So current has three paths. See, current can go in three ways. Current can go in three ways. Okay, first way is through like this, correct? Second way is through like this, and third way is through like this. Okay, So in first and second way, the path is identical. Correct? Path is identical. Only two resistors are in first and second branch. Correct? But in third way, one, two, three. See, different number of resistors are present. So I can say the current in this branch. Suppose I am taking A. So in this branch also current should be A, because see the similarity, correct? See the symmetry. Okay. So in current in this branch will be some constant B. Okay. So I can write from Kirchhoff's first law, Kirchhoff's junction rule, I can write current I is equal to A plus B. Correct. Current entering is equal to current leaving. So total current I is equal to 2A plus B. Total current I is equal to 2A plus B. Okay. See. अपन सी अभी तो देख इसमें ए करंट आ गया, सो इसमें ए एंड इन थर्ड ब्रांच इट्स बी. ओके. And let's see, the B current is coming. See, the B current is here. Okay, B current is here, and the B current can have now two options. Correct? One is this pathway, and second is this pathway. See, the both the pathways identical. Correct? If the current is going through this path, okay, like these three resistors. Correct? So current B has two identical pathways. Correct? So current will divide equally. Yes, current will divide equally. That means, yeah, B by 2 current will, yeah, B by 2 current will go through this branch, and another half will go through another branch, because, yeah, these are symmetrical. Correct? Okay, B by 2, B by 2. And next we have to see this A current. Correct? See this A current. A current is, see, A current has from, see, at this point B, A current has two options. Correct? A current has two options. See those options. A current can go through this pathway having three resistors, and can go through this pathway having only one resistors. So there is no symmetry. Correct? So current will current won't divide equally, but I'm taking some constant C. I'm taking some constant C here. So C current go through BF branch. So A minus C will go through this branch. Correct? Because A current is entering, C current is going through BF branch. So remaining A minus C current will go through BC branch. Correct? Okay. So, and similarly here also, current entering at A current entering at D junction. Correct? A current entering at D junction. And A current has two options. One option is one resistor option, and another option is three resistor option. So obviously current will follow again the symmetry. Symmetry I have used it here. What symmetry? Yes, current through this branch will be C, and this branch will be A minus C. Okay, A minus C. Okay, so let's see. So B by 2 current is coming here. C current is also reaching here. So in this branch, total current will be B by 2 plus C. And here C current B by 2. So here will be again B by 2 plus C. So B by 2 plus C plus B by 2 plus C. So it will be B plus 2C current coming through this branch. Okay, it's clear. So total will be how much current? B plus 2C. It will be like 2A plus B. Okay, so the total amount of current was entering is 2A plus B, and leaving is also 2A plus B. So okay, so we have been, see, current is equally divided now. So let's see, using Kirchhoff's second law, yeah, we can make some equations. Correct? Let me take first loop this V A B C V. Okay, I'm taking loop. Let me take loop V A B C V. Correct? Okay, I'm taking that loop. So I can write, yeah, using loop AR current. So okay, A current is going through R resistor. So AR drop will be there, plus A minus CR. Okay, A minus CR drop, which will be equal to V. Correct? Which will be equal to V. Potential gained. So I can write R into A plus a minus. So r into 2a minus c. R into 2a minus c will be equal to v. Correct? Yes. Suppose the equivalent resistance of this system is, I'm taking Req. Then I can write V is equal to 2a plus b. That is the total current flowing through this system into R equivalent. Correct? So I can write this equation as R into 2a minus c, which is equal to 2a plus b into R equivalent. Okay, clear? Yes. So we have to take another loop. Okay, let me take loop. Let me take loop C. Okay, I'm taking this loop. Which loop I'm taking? Yeah, A E F B A. Okay, I'm taking loop A E F B A. Okay, so from this loop, I can write A to E B R drop and E to F B by 2 R drop. Then F to B so against. So against I am writing opposite side of the opposite side. So it will be how much? CR again opposite, correct? Again opposite. Okay, so it will be AR, correct? Okay, so I can write here 3B by 2R. 3B by 2R is equal to R into A plus C. Okay, so RR we can cut. 3B by 2. 3B is equal to 2 into A plus C. Okay, so we have got another equation. Okay, 3B is equal to 2 into A plus C. Okay, 3B is equal to 2 into A plus C. Okay, C B by 2 R, BR B by 2 R, then CR, then okay, yeah, okay. Next we have to take another loop. Another loop from where? Let me take loop. Let me take this loop. Which loop? Let me take let me take this loop. Okay, this loop. Okay, loop E H G F E. Okay, from that loop I can write B by 2 R drop plus B by 2 plus C R drop, which is equal to EHG. Okay, so against, so it will be B by 2 plus C R. Okay, say yes. Believe that you have to include this branch also. Which branch? This branch. See, HD branch. Okay. So BR B by 2 R, then C plus B by 2. Okay, C plus B by 2. So let me take this branch. Let me take C. See this branch. So see the loop V A E F G R V. Okay, from this loop, see AR drop plus V A E. Okay, AR, no, not AR drop, BR drop, correct? BR drop plus EF B by 2 R drop, then FG. That means B by 2 plus CR drop, correct? Then GR, that is B plus 2C. B plus 2CR drop, which is equal to V. So R common, we can take common, then B plus B by 2 plus B by 2 again B, then again 1B, then 3C. So it will be 3R times B plus C, which is equal to V. Okay, so see, R into 2A minus C is also equal to V. So I can equate see this R into 2A minus is also equal to B. So I can equate 3R B plus C, which is equal to R into 2A minus C. Okay, so R we can cut. So we have another 3B plus 3C equal to 2A minus C. So I can write 3B C, I can write 3C, that 4C, which is equal to 2A minus 3B. 4C is equal to 2A minus 3B. We have another equation. 4C is equal to 2A minus 3B, and 3B is equal to 2A plus. Okay, so let me take in C form. So in terms of C, so it will be 3B equal to 2A plus 2C. So 2C equal to 3B minus 2A. Okay, 3B minus 2A. So by solving these equations, I can write 4C is equal to minus 3B plus 2A, and 2C equal to 3B minus 2A. Let me add this equation. So 6C will be equal to 0. That means C is 0. See, the main important point is there won't be any current through this branch, DH branch and FB branch. That is, C current is 0. So there won't be any current through HD and BF branch. So C is 0. So I can write 3B equal to 2A, and 3B equal to 2A. So 3B is equal to 2A. So let me see. Using this equation, 0 is equal to, okay, so we have 3B equal to 2A. That's the second equation, correct? Next, we have to find out both A and B. Correct? We have to find out both A and B. Okay. For that, we can use this equation. Which equation? See this equation. R into, now C is 0. R into 2A is equal to R equivalent into 2A plus B. Okay, we know that R equivalent for this type of circuit is how much? We know that it is 3R by 4. It is actually 3R by 4. So using that formula, I can write R into 2A is equal to 3R by 4 into 2A plus B. Okay, so R can cut. And by solving this, 8A is equal to 6A plus 3B. For 2A is equal to 3B. So by, okay, so now we can say B is equal to, yeah, B is equal to 2A by 3. B is equal to 2A by 3. Okay. So the current will be through A, then 2B will be how much? 2A by 3. Okay, it's clear? Yes. Okay, so let's move to next question. Yeah, the next question is, the distance between the two plates of a parallel plate capacitor is doubled, and the area of each plate is half. If C is its initial capacitance, its final capacitance is equal to. Okay, the question is simple. It's about a parallel plate capacitor. Okay, see, this is the typical picture of a parallel plate capacitor having two plates parallel to each other. Okay, plate 1 contains positive charge and having surface charge density sigma, and plate 2 containing negative charge and its surface charge density is negative sigma. Okay, so obviously the electric direction of electric field will be from, yeah, plus to positive charge to negative charge, correct? So electric field lines will be like this. Okay, yes, and the separation between the plates, the distance between two plates is d, distance between two plates is d, and the area of each plate is a. So area of each plate is a, and the surface charge density is sigma. So the total charge will be here. We know that sigma is equal to q by a. Total charge will be here a sigma, and here it will be minus a sigma. Okay, clear? Yes. And see, using these equations, the capacitance C of the parallel plate capacitor is capacitance C of the parallel plate capacitor is, the formula is A epsilon naught divided by the capacitance of a parallel plate capacitor is given by C is equal to A epsilon naught divided by. Okay, how did we get this equation? Let me solve this. See, the electric field here, the electric field present between region 1 and 2, that is between plate 1 and 2, that is inside the plate, electric field here will be how much? Yeah, because of plate 1 electric field will be sigma divided by 2 epsilon in this direction, and also due to plate 2 also same direction, that is sigma by 2 epsilon. So net electric field will be sigma divided by 2 epsilon into 2, that is net electric field will be sigma divided by epsilon naught. So electric field present here is sigma divided by epsilon naught. Okay, and we know that, so the potential difference between the plates will be equal to E into D, and E is sigma divided by epsilon naught into D. Okay, I can write sigma in terms of Q by A, correct? So I can write Q by A epsilon naught into D. This is the potential difference, and we know capacitance C is equal to Q by V. Okay, capacitance C is equal to Q divided by V. So Q divided by Q D divided by A epsilon naught. Q I can cut, and the capacitance C is equal to A epsilon naught divided by D. So the capacitance of a parallel plate capacitor is A epsilon naught divided by D. Okay, that's clear. So that's the formula for the capacitance of a parallel plate capacitor, that is C is equal to A epsilon naught divided by D. Okay, where A is area of each plate, where A is area of each plate, and D is distance between the plates. Okay, distance between the plates, and epsilon naught is permittivity of free space. Okay. So the in question it's saying is the distance between the two plates of a parallel plate capacitor is doubled. Okay, so distance is doubled. Okay, let me take initial capacitance C. Initial capacitance C, which is equal to A epsilon naught divided by D. Okay. Now we have to find out the final capacitance. I'm taking final capacitance as C dash. So C dash will be A dash epsilon naught divided by D dash. Okay. So A dash we have to find out in terms of A, and D dash also we have to find out in terms of D. It's saying parallel distance between the two plates of a parallel plate capacitor is doubled. Distance is doubled. Distance is doubled means D dash will be how much? 2D. And the area of each plate is halved. Area of each plate is halved. So area is A dash is A divided by 2. Okay. So we have to find out. So it's very easy, It's actually very easy question. So C dash will be equal to A dash is how much? A by 2 into epsilon naught divided by D dash is 2D. So you can take C dash is equal to A epsilon naught divided by D into 1 divided by 4. What is this initial capacitance C? So C dash is equal to C divided by 4. C dash is equal to C divided by 4. So the final capacitance is equal to initial 1/4 of the initial capacitance, that is C divided by 4. Clear? Okay. Yes. Okay. Let's move to next question. We have a wire loop. A wire loop is rotated in a magnetic field. A wire loop is rotated in a magnetic field. The frequency of change of direction of the induced EMF. Okay. See, from Faraday's law, we know that the magnitude of the induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. That's clear. The induced EMF is equal to minus d phi b divided by dt. See, the magnitude of the induced EMF in a circuit is equal to time rate of change of magnetic flux through the circuit. Okay, so here the condition is a wire loop is rotating in a magnetic field. A wire loop is rotating in a magnetic field. Okay. Okay, I have got a question now. Physics MBBS में कितने percentage use होती है? Okay, see. In general speaking, MBBS is about human body. So we don't deal direct with the physics. Okay. So there is no direct using of physics. But see, basic mathematics, basic physics is required for like calculating hemoglobin and for blood analysis and all. Okay. We have to be in touch with physics. Like we cannot say how much percentage is using in MBBS, but yeah, like the basic physics is required. But for NEET, anyways, there is no option. We have 45 questions, so we have to solve here. Approximate 40, above 40 we have to solve. So physics is very important. Okay. Physics is actually rank deciding. I think it's been clear. Okay. So let's discuss this. Okay. Suppose this is the magnetic field B, and its direction is into the plane, not into the plane. Okay. Direction is into the plane. Okay. And we have a rotating loop. I'm taking a ring here. And ring is rotating. Okay. Ring is rotating with velocity, angular velocity omega. Okay. Ring is rotating with angular velocity omega. Okay. This is also a basic question. See, now the ring is rotating. Okay. So at any time, the area vector of ring and magnetic field B, suppose making an angle theta, then flux will be how much? Magnetic flux will be simple B dot A, or I can take BA cos theta. This is the basic thing. Any loop in any magnetic field, the area vector A and the magnetic field B is making theta angle. So the magnetic flux is BA cos theta. Correct? So here theta is changing, correct? Because why theta is changing? Here the loop is rotating. And that change in theta will be, I can write in terms of angular velocity, that is omega into t. Theta equal to omega into t. So magnetic flux phi b, I can write BA cos omega t. BA cos omega t. Okay. So we know induced EMF. What is the formula of induced EMF? Induced EMF is minus d phi b divided by dt. So induced EMF is equal to minus d phi b divided by dt. Minus d phi b divided by dt, that is BA. We have to differentiate minus BA d by dt of cos omega t, and that will be minus sin omega t. So minus it will be positive. So we will get BA sin omega t. So induced EMF E is a function of sine, correct? Induced EMF is a function of sine now. So induced EMF is a function of sine now. So we can represent in a graphical form induced EMF, correct? Because it's now in a sine function, correct? So sine function. So taking y-axis for induced EMF and x-axis for time. Okay. So see, for one cycle, I can say for one cycle, the first induced EMF direction is, then it's becoming negative, correct? So one change and another change. So for one cycle, I can say the frequency of change of direction of the induced EMF is 2. So for one cycle, it will be 2. For one cycle, it will be 2. Okay. Again, I am telling this is not about how much percentage physics we can use in MBBS. Yeah, physics is very important for NEET. Correct. Physics is as equal important as biology and chemistry. See, biology is easy. We can almost solve almost every questions. Correct. If you read NCERT very well, we can solve almost every questions from biology. But physics is you have to practice problem. At least correct. See, nowadays the questions are very easy. Very easy means if you know the basic equations and the applications of the basic equation, we can solve above 40 questions. That means out of 45, we can solve above 40 questions from basic. See, these questions are like series question. Formula of capacitance is A epsilon naught divided by D. If you know the formula, see the question is piece of cake. Yeah, we have to just area is halved and distance is doubled. So just using this equation, we can solve this question, correct? So never underestimate physics if you know all the equations and applications of these equations. Okay, we have been taking sessions for physics, so please do watch. So like don't think like how much percentage physics is in MBBS and all. Now focus on NEET exam. Okay, after clearing NEET exam, you will understand. Okay, yes. So yeah, this question is over. Okay, let's move to next question. Okay, this is again a beautiful question from mechanics. Okay, this question is also C. I can say like average question. NEET most questions are like easy questions and only like 35 questions I can say easy type question, and like 5 to 7 questions are like average, and barely 3 to 5 questions are like tough questions. That see, let me take a analysis. Okay, so we have 45 questions from physics. Okay, and we have 45 questions from chemistry, and we have 90 questions from biology. Okay, so see if you read NCERT thoroughly, minimum 2 times, you can solve easily 80 plus question. 80. I'm taking 80. Okay, I'm taking 80 question. Okay, and chemistry is also like yeah 40 questions you can solve. So 80 plus 40, 120 questions. 120 into 4 means how much? 480. So you have got 480 now. Okay, see the physics. See, actually physics is the rank deciding subject because the first is time. The first problem I have faced, everyone will face that. Everyone is facing is time. Okay, time is the, I would say, the most priority villain for physics. Time. Okay, we have to solve questions within time. Okay, second is we can see equation should be at pen tip. All equations, all basic equations, all important formulas. Okay, so suppose if you can solve 35 questions, that 35 questions is in easy category. If you can solve 35 questions, so 35 into 4, how much? 0 to 140, correct? 480 plus 140, how much? 0 to 620. 620 mark. Okay, nowadays 620 is also not a good mark for getting top colleges. So see, you will have to work hard for physics. Because I'm saying you will have to work hard for physics. Okay. Okay. So I would say from physics you have to score 40, like chemistry only, because nowadays questions are very simple. See, the 40, 35 to 40 questions are from easy side. Okay, if you solve that plus 5 question, that will add 40, that will add 20 marks. So you will have a 640 marks. This will be a good mark, according to me. Okay, nowadays, like it's like trend is going like 660 and all. For that, you have to solve 85 questions from biology also. Okay, yes. So, okay, let me solve this question. We have an electric lift. Okay, an electric lift with a maximum load of 2000 kg. Okay, electric lift with a maximum load of 2000 kg is moving up with a constant speed of 1.5 meter per second. And the frictional force opposing the motion is 3000 Newton. The minimum power delivered by the motor to the lift in watt. Okay. See, the question is very simple. The basic formula used in this question is what? Power. We have to find out the power. The equation of power is equation of power yeah, F dot V. Correct. F into V. If we know the total force and we know the velocity here, velocity is given 1.5 meter per second. So the power will be force into velocity. Okay. So the first thing is we should know the equation. Okay. The equation is power is equal to force into velocity. Okay. Next is, see, if you have solved one type of this question, you could have easily solved n number of similar questions. Like, see, let me show you the diagram and let me explain. See, suppose this is the lift. Okay, this is the lift. This is the lift. Okay, and passengers are standing inside the lift. Okay, and lift has a lift cable. Correct. This cable is actually holding the weight. This cable is actually holding the weight. So, saying the total load of the lift, that is itself lift mass plus passengers mass. That means including both is 2000 kg. So 2000 kg is the mass. So the weight feeling downward will be how much? Weight will be 2000 times g. Correct. 2000 times g. The weight will be 2000 times g. Okay. And the frictional force opposing the motion. Frictional force opposing the motion. Lift is moving upward. Correct. Lift is moving upward. See, is moving up. It's clearly mentioned in the question. It is moving up. It is moving up with a constant speed of 1.5 meter per second. It's moving up with a constant speed of 1.5 meter per second. So lift is moving up. Friction is always opposes the motion. Correct. So frictional force opposing the motion is 3000 Newton. So frictional force is also directing towards ground. That is the frictional force. I'm taking Fr is equal to how much? How much it's given? 3000 Newton. 3000 Newton. So weight is 2000 G. So 2000 G. If suppose I'm taking G as a 10. So the weight will be how much? Weight will be 20,000 Newton. Correct. Weight will be 20,000 Newton. So the total downward force is 20,000 Newton weight plus frictional force, that is 3,000 Newton. So the lift, see, lift cable, so cable has to have a tension of 20,000 plus 3,000, that is 23,000 Newton. Then only it will move with the constant velocity. Correct. So the tension in the cable is 23,000 Newton. This is the tension in the cable. Okay. So this tension is actually the force here. Correct. So the power will be power delivered by the motor to the lift. In what will be power will be simply the tension T here into velocity. So T is here 23,000 Newton into velocity is 1.5 meter per second. Okay. See, if you got this problem 23,000 into 1.5. See, I can write it 1.5 as 3 by 2. See, ऐसा लिखेगा तो it will be easy, correct? How come? See, 2 dividing by 2 is very easy. It's like 1 500 into 3, 0, 0, 3 into 5, 15. One remaining, 4, 3. Correct. The answer will be 34,500 watt. Answer will be 34,500 watt. 34,500 watt. Okay. This is the frictional force opposing the this is the minimum power delivered by the motor to the lift in watts. Clear? I hope it's clear. Okay. Yes. Let me move to next question. This is again a very simple question. This is from previous questions, I guess. Again, very simple question. See, we have a square loop. We have a square loop of a side 1 meter and a resistance of 1 ohm is placed in a magnetic Tesla. The plane of loop is perpendicular to the direction of magnetic field, the magnetic flux. Okay. See, if you get this question, the first thing is, do you know about magnetic flux? Okay, if you know about magnetic flux, what is the equation of magnetic flux? See, the magnetic flux is actually very simple. See, suppose the magnetic direction of magnetic field is like this. This cross means magnetic field is going inward, going into the plane, going into my tire. Okay, this is the magnetic field, direction of magnetic field. And I have placed a loop, a loop, a loop, anything. Okay, here it is actually a square loop. Okay, it's actually a square loop. So let me. Okay, excuse me. Sorry for that. Okay. So see, the formula for magnetic flux phi is B dot A. Correct. B dot A. And A is area vector and B is magnetic field. The concept of area vector is, you should be clear with that. Okay, how can we find area vector? See, I have a plane here, plane lying in XZ plane. Okay, plane is in XZ plane. So the area vector will be here. Area vector will be along y direction. Area vector is along y direction. So area vector I can take A into J cap. Okay, suppose another scenario. Okay, we have another scenario. this is X, this is Y, this is Z. Okay, X, Y, Z. Okay. Now plane is lying in XY plane. Okay. Now the plane is in XY plane. So the area vector will be perpendicular to the plane of area. So here area vector will be along Z direction. So here I can take area vector I can take area vector is equal to area into which direction? Z cap. Correct. Z cap means K cap. Z cap means K cap. Okay, it will be minus K cap. Okay. And similarly, let me discuss another scenario. This is another scenario. Okay, this is another scenario. X, Y, Z. Okay. Now the plane is lying in YZ plane. Now the plane is lying in YZ plane. Okay. So here the area vector will be, the basic funda is area vector is always perpendicular to the plane. Okay. Always perpendicular to the plane. So here the area vector is along X direction. Along X directions means here it is I cap. Correct. So the concept of area vector, how to find out area vector, you have to know that area vector is always perpendicular to the plane of area. Okay, that is equal to B dot A, that is BA cos theta. Theta is the angle between area vector A and magnetic field. Note is like angle between magnetic field and area. It's angle between magnetic field and area vector. Okay, area vector. And here it is saying if the plane of the loop is perpendicular to the direction of magnetic field. Okay. In question, plane of loop is perpendicular to the direction of magnetic field. Okay. So here also let me take XYZ axis. Okay, let me take XYZ axis. Okay. This is X, this is Y, this is Z. Okay. Plane of the loop is perpendicular to the direction of magnetic field. So suppose let me take direction of magnetic field as K cap, means along this direction, okay, along positive Z direction, so magnetic field is along positive Z direction. Okay, yes. And the plane of the loop is perpendicular to the direction of magnetic field. Plane of the loop is perpendicular to the direction of magnetic field. Plane of the loop is perpendicular. See, the plane of the loop is perpendicular. The loop should be like this. Plane of the loop is perpendicular to magnetic field. Plane of the loop is perpendicular to the direction of magnetic field. Okay. Now, so if this is the plane of the loop, so plane is lying in, now the plane is lying in XY plane, correct? Plane is lying in XY plane. Plane is lying in XY plane. Okay, we have discussed before, if the plane is lying in XY plane, the area vector will be along minus Z direction, that is K cap direction. So here area will be K cap in terms of K cap, and magnetic field is also in K cap. So theta will be here how much? Yes, theta will be 0. Theta will be 0 or 180. We can take anything. So the flux phi will be equal to BA cos theta, that is BA cos 0. What is cos 0? Cos 0 is 1. So the magnetic flux will be B A. Magnetic flux will be B into A. So in this question, the magnetic flux will be just multiplication of B into A. That is, here magnetic field is 0.5 Tesla, into square root of one side. That means 1 square. So it will be 0.5 only. The flux will be 0.5. I hope it's clear. The concept of finding area vector A. Okay. If you find the area vector, you can easily solve using B dot A, that is BA cos theta. Okay. So let's discuss next electric dipole. Okay. Electric dipole. Okay. Electric dipole. See, simple electric dipole is actually what? Electric dipole is two charges, two similar but opposite charges separated by a distance 2a. That is the basic concept of electric dipole. Electric dipole is two charges, take any two charges that should be similar and in opposite. Similar and opposite. So an electric dipole is a pair of equal and opposite point charges q and minus q separated by a distance 2a. And the distance of separation should be 2a. Distance of separation should be 2a. So an electric dipole is basically equal and opposite point charges q and minus q separated by a distance 2a. Okay. The line connecting the two charges defines a direction in space. By convention, direction from minus q to plus q is said to be the direction of the dipole. So this is the dipole. So basically, what is dipole? Dipole is two point charges minus q and plus q separated by a distance 2a. Okay. And next is what is dipole moment? What is dipole moment? What is dipole moment? That is vector p. What is dipole moment? That is vector p. Dipole moment is it's a multiplication of charge into separation. That is q into 2a. And the direction of dipole moment is minus to positive. So this will be the direction of dipole moment, and the value of dipole moment is q into 2a. That is either of the charge into separation. So this is electric dipole and this is dipole moment. It's clear. And the two common questions asks from electric dipole is electric field due to a dipole and as well as electric potential due to a dipole. Okay, this has been taken from NCERT only. Electric field due to a dipole and electric potential due to a dipole. The first is electric field due to a dipole. Electric field due to a dipole. They have two scenario. First is suppose this is the electric dipole. Okay, this is electric dipole, and we have a point on equatorial line. And there will be minus p divided by 4 pi epsilon naught r cube. 4 pi minus p divided by 4 pi epsilon naught r cube. And the second scenario is we have an electric dipole along the axial line. The electric field is 2p divided by 4 pi epsilon naught r cube. Okay, and for potential, similarly, the equation is 1 by 4 pi epsilon naught p dot r divided by r square. I can also write k into p r cos theta divided by r square. Okay, so I'm concluding my session here. I hope everyone understood what I have taught today. Okay, so all the best for your future exams and study hard. Okay, physics is easy if you know the concept. Okay, so thank you everyone. Let's meet in next session. Okay.